Alright, hello, welcome back, happy Tuesday. This I am using as notes, so I'm going to write all over this, and I have a different worksheet for you to work from. A couple things to talk about first. We're looking at end behavior. What's happening at the end of the sketch or the graph of this function, x cubed minus 3x squared minus 3? Just the ends. And there are some options. You will have graphs that generally are going to follow that shape, or they might open downward, or you might have something that raised to a different power might come up, cross over, and these can be above or below an axis. We can also have something that maybe comes down. Oops, a little too much of a squiggle. So what we're looking at here is what happens at the ends. As you can see from the orange, we have one arrow on the left-hand side, this being kind of the axis of symmetry, and then one arrow that is going downward on the right-hand side. So our end behavior using arrows would look like this. If we look at this one, we have this arrow going up, and that one's on the right, and we have this arrow going down, and it's on the left. So that's what our end behavior would look like with arrow notation. When we look at this red one, we have an arrow tip there, arrow tip there. So on the left side it's going up, and then also on the right hand side it is also going up. If we look at the blue one, we have an arrow tip down there and an arrow tip down there. So our arrow notation will look like down, down. So that's kind of the background of what we're talking about here. So how do we tell what's what? First off, we're going to look at two blanks. We have a right blank and we have a left blank. The right blank is determined by the sign in front of your function. This is written in descending order 3, 2, and a constant, so it's in standard form. And this is a positive sign here, and positive means up. So the right hand blank will be determined by that sign in front of our function. The left hand is going to follow this kind of quick tip. Odd, opposite. So if we have an odd exponent, let's change colors here. If our exponent is an odd number, 3, 5, 7, 9, etc., then the arrow is in the opposite direction as the one we first wrote. If we look at number 2, let's pick a different color. I have two blanks to fill. The right-hand blank is based on the sign. The sign is negative, so that sign points downward. The other side, if we look at this, we have even is both. So both arrows will be in the same direction. So we have odd, opposite. If the exponent is odd, the left arrow is in the opposite orientation than the right arrow. If the exponent is even, then it means both arrows are in the same direction. So let me pull this down a little bit. I have two blanks to fill. I look at the sign first, it's positive. Positive means up. If I look at the exponent next, exponent is odd, odd, opposite. That means this one has to go down. If I look at the next one, number 5, Number 5, let's go back to this. If I look at the sign, right arrow is down. If I look at the exponent, exponent is odd. Means the other arrow is in the opposite orientation. So that's what end behavior is, using arrow notation. There is another notation. We may or may not get to that before we get to the final exam. If we don't, then obviously the only thing you'll be responsible for is the arrow notation. But for now, let's just make sure we understand. Right side is based on the sign. Left side is based on either an odd exponent or an even exponent. Good luck. Have fun.